Hello and welcome back to my YouTube channel again. So in the last video we have covered about logistic regression. So if you didn't remember, I will just give you a percentage how much we got, so you can go and check out the last video. So logistic regression, we got an accuracy of 89%. So just a quick recap. So all the notebooks are here in this repo, so you can go and just download it and try to use it in your local PC. And if you want to follow me, you can use my Kaggle profile to follow me, and I have a link here. You can go and connect with me anywhere, like LinkedIn, YouTube, blogs, and everywhere. You can go and connect it there. So moving ahead, I'll just go directly to a KNN. So what basically KNN is? So KNN is nothing but a K nearest classifier. So what it does is it's do the same thing as a classifier algo does, but the only thing is it uses a shortest distance approach. So let's assume that this is a new data points that comes to this whole distribution. This is red one category and the green is next one. So if this point comes, it will try to calculate the difference between this, like the closest point from the green area and the red area. So it's very closer to the red one. So in the next part it will become the category one and add it to here. So and to find the distance, it uses a distance called Euclidean distance. You must be heard about it. Like it will take this subtraction of both the distance and square it and add the subtraction, like y1 y2 x. It's take the coordinate of this x and y and do the subtraction and square it. So you can go and read more about it if you want. So I will directly go and kernel clear all output. Yeah, so just start with importing, as usual, importing all the important libraries. And for the consistency, I'm using the same CSV that we have used earlier, also the social media ad, where we try to find the classifier model based on age and the salary. So again we do the sort of same thing here. We try to plot the count plot, and as I've mentioned about class imbalance, so we are not taking too much consideration there. We can neglect it for now. And again checking the null values and sort of that thing. So now, as I've said, age and estimated salary that we are going to use as a x feature, and the y, the predictor, which we have to predict, is the purchased, whether it is purchasing or not. So yeah, let's take the shape and everything. Same thing, 25% as test and other 75% as training. So if you have watched the last video, you must have get it's very common, it's very consistent across. So if you have missed anything, just go and watch that video please, because that can give you a very clear idea about it. And in the last video I have explained about why I used fit transform in the train part, but I didn't use fit transform in the x test. So I have explained it there. I don't want to explain again and again, so just go and watch that video. So we do the standard scaling so that all will be in the same sort of range. So we here create the classifier, and we try to, here the first thing we gave is neighbor. N neighbor is how much neighbor you want. So n neighbor is as a parameter equals to 5, and it's a default parameter, and the metric is also default, and p is also default. So it's one of the parameter. You can read more about it. Just go to sklearn and just search for k nearest neighbor classifier. So yeah, and the module, sorry I didn't explain about the module that you use. So for k neighbor classifier, I have used sklearn.neighbor and import k neighbor classifier. And for logistic regression thing, I have used is sklearn.linear model. I have imported logistic regression. So yeah, I will directly go here and I will start again from here. So yeah, let's visualize the training set data. So it's taking a bit of time because I guess the data set is pretty huge, or what, I don't know. It's sort of same. So yeah, it's take a very small time. So let me run the below one also so that we can see. So let's talk about some modules, not modules, some metrics. So what basically metrics? So I have explained more about metrics here. We have very close to this accuracy part. So if you don't know about what accuracy is, precision is, recall is, and F1 score is, you can learn more about it in details by using this confusion matrix trick. So just go and read more about confusion matrix so you can get more clarity on it. So yeah, as you can see here, we got, so just the one context here, that when we use logistic regression, we sort of see that it's a linear line dividing both the classifier, because although it's at the end it's a linear classifier, but it's not a linear. It tried to make an area here. As you can see, it's like sort of a map here. So yeah, it's a difference, one of the very like large difference between all the classifier and the logistic regression classifier and KNN classifier. So let's see, let's directly jump into this confusion matrix and the accuracy and precision. So as you can see, 4 plus 3 is the 7 is the inaccurate value, and here how much we got, 8 and 3 is like 11. So yeah, it's like sort of very accurate. So let's import into like a data frame. Now you can see our model is 93% accurate, and in logistic regression it was only 89%. So yeah, as we can say that our KNN model is far more better performing than logistic regression. So it's very simple because of that linear lines, but we can't say that KNN is much more powerful than logistic regression, because it's totally depend on the type of data we use. Sometimes a simple linear regression solve the problem, but sometimes like very complex algorithm like XGBoost or random forest doesn't able to solve it. I hope this helped you guys. So if you like this video, give us a thumbs up and see you in the next video. Thank you and have a nice day. Bye.